In this video, I'm going to show you how you can divide polynomials fast using synthetic division. Let's get into it. For my first example, I've got x cubed plus 2x squared take x plus 3, and we're trying to divide it by x take 2. The basis of synthetic division is to get rid of all of these x's, so we don't have to write them down every time that we do a calculation. So we want to get rid of these x's, and what we do is we code it. So we use all of the coefficients in front of the x's only. I'm going to set up synthetic division like this. Usually we go under, so we go a line down and then a line underneath, rather than our traditional division where we put the line on top. So in this case, I've got a coefficient of 1, a coefficient of 2, -1, and 3. Now these need to be in order. So third power, second power, first power, and then constant. So that's the way we're going to put it through. So 1, 2, -1, and 3. That's how I set it up. This is the divisor, x take 2, that's what we're trying to divide from. Now we need to put the opposite of this number. See, it says -2, so we're going to put +2 here. Okay, now the process works like this. For the first number, we just bring it down, bring this little arrow, and this is going to be my answer. This is going to be my quotient. And I'll put the number here, so 1. It just goes straight down here. Now the second part is we grab this 2, and we multiply it by 1, and we put the answer over here. So 2 times 1 is 2, so I'm going to pop 2 there. The next part is once we've got this column set up, we're just going to add those two numbers together. So 2 plus 2 is 4. Okay, and we go again. 2 times 4, put it up here. 2 times 4 is 8. Next bit, -1 plus 8 is 7. Again, 2 times 7 becomes 14. 3 plus 14 is 17. Once we've got the numbers, we need to decode it. So to decode, I do this. The last number is always the remainder. So I just go R for remainder, and I go backwards. C for constant, x squared. And if you had more, they would go back further as well, depending on how big your polynomial is. So now I've got this, I would write my answer. This polynomial divided by this would be x squared. So I go 1x squared plus 4x plus 7. That's my constant. And then I've got the remainder. So I've got a remainder of 17. So 17. And our remainder we divide by our little divisor here, so x take 2. So that's the answer to this, using synthetic division. Now, you might want to answer it this way, or you might be asked to just factor out this divisor here. So you can write it another way. This is what our polynomial is. And if we just wanted to factor out the x take 2, we would write it like this. We say x take 2 out the front, and then we write our quotient, which is this part, x squared plus 4x plus 7. And then plus our remainder on the end. And so that's more of a factored form plus the remainder. So 2 ways you can actually answer that question, depending on what you're asked for. Let's do another example. 2x cubed take x squared plus 3x take 1, and divisor is going to be x plus 3. So we'll go a little bit faster this time. We set it up for synthetic division. We pop our numbers in. 2, -1, 3, -1. We put the opposite of this number. So it's x plus 3, so I'm going to put the opposite of this number. Instead of +3, I'm going to put -3. Let's start the process now. So we bring the 2 down, pop it down here. -3 times 2 is -6. Pop it here. -1 plus -6 is -7. Bring it down here. -3 times -7 is +21. Pop it here. 3 plus 21 is 24. Write it here. -3 times 24 is -72. Pop it here. -1 plus -72 is -73. All right, and then I'll just decode and say, that's my remainder, that's my constant, that's my x to the power of 1, that's my x to the power of 2. Okay, so let's write the answer now. So the answer, the quotient up here is going to be 2x squared take 7x plus 24, and then our remainder, which is -73, over what we're dividing by, which is x plus 3. Or if you wanted to just factor out this x plus 3, again, we could rewrite this polynomial like this and say x plus 3 out the front, our quotient, which is 2x squared take 7x plus 24, plus our remainder, which happens to be -73. Our final example is this, 4x cubed plus 3x take 7 divided by x take 1. Now, if you look closely, you'll realize that we don't have an x squared here. So what do we do in this case? It's exactly the same as when you do long form polynomial division. We need to add it in. Right, so I'm going to put it in here, except my coefficient's going to be 0. So I've got x cubed and I've got 0x squared here. 3x's, so on and so forth. And then we can do exactly the same thing. So let's just set that up. Write our numbers in. 4, 0, 3, negative 7. Our divisors x take 1, so we're going to put plus 1 here, so 1. All right, we could do this pretty fast now. Bring the 4 down, write it down. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 is 4. 3 plus 4 is 7. 1 times 7 is 7. Negative 7 plus 7 is 0. Okay, and then I'll just decode, put my remainder constant x squared, just so I remember what those numbers actually mean. And you notice we've got a remainder of 0 here. So that means that this is actually a proper factor of this polynomial. We're not going to have a remainder. So let's just write it up. It's 4x squared plus 4x plus 7. No remainder. So this is the actual full answer for this here. Or if we wanted to just factorize out x take 1 from our original polynomial, it would look like this. So we're going to factor out x plus 1. So we bring x plus 1 out the front, and we have our quotient here, which is 4x squared plus 4x plus 7. So synthetic division is awesome. It's really, really quick. Too good to be true? Maybe. There are only certain cases where you can use this type of synthetic division. And that is when you're dividing by monic linear factors only. So you can divide by monic linear factors only. What does that mean? Well, I'll put some monic linear factors on the screen for you. X plus 1, monic linear factor. Monic means that there has to be a 1 in front of the x. X take 2, that is a monic linear factor. It's got a 1 in front of the x. X plus 15, again, monic linear factor. So any of these types of ones we can do. When can't we use this type of synthetic division? Well, when we don't have a linear factor. This is a quadratic factor. It's got a squared in it, x squared. So it's not going to work in this case if we're trying to divide by this. Something like this. This one's non-monic. It's got a 2 in front of the x, a coefficient of 2. And one more example that we can't use a negative here. So this is a negative monic linear factor. We need a positive monic linear factor. This needs to be a positive one here. So as long as you have a monic linear factor as your divisor, you can use synthetic division. And I always recommend you do synthetic division because it's fast. Well, I hope that video was useful to you. If it helped you out, don't forget to press the like button. Lets me know that you're watching the video and that you need more content just like this.